As of February 2026, the Artemis 2 mission is finally on the pad at Kennedy Space Center, preparing to launch the first humans around the moon in over half a century. This mission is a critical test before Artemis 3, scheduled in 2028, that will bring humans back to the lunar surface. But while the world watches the SLS rocket ignite for this critical flyby, a much quieter countdown is happening in Beijing. To understand how China could realistically win, we have to analyze the China Lunar Exploration Program. While the West focuses on collaboration between public and private, with companies such as SpaceX, the China National Space Administration, the CNSA, has established a roadmap that is locked into a 2030 landing date. And unlike NASA, they don't face the volatility of shifting political administrations or annual budget debates in Congress. The heart of China's strategy is the Long March 10 rocket. As of February 2026, the CNSA has already completed static fire tests for the high-thrust engines of this vehicle. Their mission profile is simpler. Instead of one massive rocket, they will launch two Long March 10s in quick succession. One carries the Lanhua lunar lander, and the other carries the Mengzhou crew spacecraft. They meet in lunar orbit, dock, and descend. By using this modular approach, China avoids the need for a super heavy class rocket that requires years of untested orbital refueling. They're using proven orbital rendezvous technology, the same tech they perfected with their Tiangong space station, and apply it to the moon. In contrast, NASA's Artemis program is currently caught in a complexity trap. The architecture is technically brilliant, but logistically fragile. The Space Launch System, SLS, is a powerhouse, but at roughly $2.2 billion per launch, it is an economic outlier. The real bottleneck, however, is the Starship Human Landing System, HLS. To get a Starship lander to the lunar surface, SpaceX must perform 10 to 15 orbital refueling launches to fill it with cryogenic propellant in low Earth orbit. As we stand here in 2026, large-scale cryogenic fluid management, keeping liquid oxygen and methane from boiling off in the vacuum of space, remains an unsolved engineering hurdle at this scale. Furthermore, NASA is currently managing significant setbacks. The Artemis 2 launch we are seeing now was delayed by nearly 12 months due to technical anomalies with the Orion heat shield, which eroded unexpectedly during the Artemis I re-entry. Then there are the Axiom Next-Gen spacesuits, which are currently facing cooling system pressure issues. These aren't just minor problems. They're systemic delays that push the actual landing mission, Artemis 3, into a realistic window of late 2028 or even 2029 that if NASA encounters even one major anomaly during the refueling demonstration scheduled for later this year, the US timeline will slip into 2030, the exact moment China is scheduled to arrive. Engineering challenges aren't the only obstacle. The most significant advantage China holds isn't technical, it's administrative. The U.S. space program suffers from budgetary whiplash. NASA manage many programs other than Artemis, and the budget from federal government is cut more and more every year. Also, the cooperation between us and other countries can make a big difference because they have even less money to work with. China, by contrast, operates on a wholly off-government strategy. Their space funding is woven into the 14th and 15th five-year plans. The CNSA has a stable budget, planned and deeply integrated with their defense sector. But why does being first in the 2030s matter so much more than it did in 1969? Because of lunar resources. This isn't a flag-planting exercise, it's a gold rush. The primary target for both nations is the lunar South Pole, specifically the Shackleton crater. This region contains billions of tons of water ice in permanently shadowed regions. In space, water is more than hydration, it is propellant. By splitting H2O into hydrogen and oxygen, you create a gas station for the entire solar system. Whoever reaches these craters first can establish safety zones under the current and highly debated legal frameworks of the Artemis Accords and the Chinese ILRS. International Lunar Research Station. Beyond water, there is the promise of helium-3. This isotope, rare on Earth but abundant in the lunar regolith, is the holy grail of energy. It is the ideal fuel for clean nuclear fusion, capable of providing carbon-free energy for centuries. China has already incorporated helium-3 research into its national strategic priority list. Then there are the rare earth metals, yttrium, neodymium, and others, which are vital for everything from AI chips to EV batteries. If China secures a monopoly on lunar mining, they secure a monopoly on the 21st century global economy. The consequences of China winning this race are geopolitical and long-lasting. If the first permanent base on the moon is the ILRS, the international community will pivot toward Beijing for space standards, docking protocols, and resource rights. We already see Russia, Pakistan, and various Middle Eastern nations signing onto the Chinese lunar roadmap. Achini's victory would signal a definitive shift in global soft power, marking the end of American technological hegemony. As we look at the telemetry in February 2026, the race is a dead heat. NASA has the more powerful hardware, but China has the more reliable process. The winner won't necessarily be a nation with the most genius engineers, but the nation with the most consistent logistics. The moon is no longer a destination. It is the ultimate high ground of the new industrial age.